Hello viewers, welcome to DSP playlist. So in this video lecture, we are going to see about how to design a low pass filter for a given desired frequency using the frequency sampling technique. Here for this design, the length is given as n is equal to 9. So in previous cases, we have discussed about how to design a FIR filter using the Fourier series method and the windowing method. Here we are going to design a FIR filter using the frequency sampling technique. So what are the let's we see what are the steps involved in designing the FIR filter design. Step 1. Step 1 is you have to find the samples at desired frequencies. That is, first you have to write this h of k is equal to h, that is a desired response, e power j omega, that is which is equal to e power minus j n minus 1 by 2 omega. Here in our problem n is given as an 9, so that n minus 1 by 2 is equal to 9 minus 1, 8, 8 by 2 is equal to 4. And similarly omega, so we have samples, the samples are taken at the frequencies, that is omega is equal to 2 pi by n into k. Okay, so after substituting this, so my h of k is equal to e power minus j 4, n minus 1 by 2 is equal to 4, and omega is equal to 2 pi by n is equal to 9, so that 2 pi by 9 into k. So my h of k is equal to e power minus j, that is 8 pi by 9 into k. So first step over, that is you have to find the h of k values. So the next step, for what different samples of k you have the frequency response. To find the different k values for our frequency response, you have to draw the unit circle. You have to draw the unit circle, that is to find the k values. Draw the unit circle. Draw the unit circle. Before it, you have to divide, that is the you have to divide the 360 degree, that is I am going to take the angle as theta as 360, that is a 2 pi by, I am bisecting the circle of 360 degree into n number of sample, that is n is equal to 9. So for this k value, that is 360 by 9 is equal to 40, that is 40k by 9. So I am bisecting the k values is, the k value is equal to 0 to n minus 1. K value is equal to 0 to n minus 1 and k is equal to 0 to 8. So I am bisecting the circle into 8 equal parts with the angle of 40 degree. So why I am bisecting the circle into 8 equal parts is in order to find the k values. That is, I am taking the samples for the desired frequencies. So this one is the 0. So this one is the angle is 0. It is centered. So I am bisecting this. So 40. So this one is 90 degree. So 90. This one is 0, 40, 80, 120 plus 40, 160, and then this one is 0, 90, this one is 90, 0, 180, 270, and then 360, 160, and then 200, 240, and then 280, and then 320 and then 360. Okay, so I am bisected the circle of 2 pi radian into 8 equal parts. So this one is k is equal to 0, that is k is equal to 0, k is equal to 1, k is equal to 2, this one is 3, 4, 5, 6, 7 and 8 equal parts. So see the frequency response. The frequency response is e power minus j n minus 1 by 2 of omega. It is between 0 and pi by 2. It is between 0 and pi by 2. See, between 0 and pi by 2, this one is a 90 degree. So between 0 and pi by 2 is nothing but a 90 degree. The pi by 2 is in radian. If it is an angle, it is 0 to 90 degree. For 0 to 90 degree, what are the samples? What are the samples which we can take in this frequency ranges? For k is equal to 0, for k is equal to 1 and for k is equal to 2. Okay, so my response is, that is, I am picking the step 2. Step 2 is, I'm just, for what values of samples I am having the signals. So h of k value is here e power minus j 8 pi by 9 k for k is equal to 0, 1 and 2. Okay, and similarly the value is 0, that is the response is 0 for k is equal to, see, 3, 4, 5, 6. 3, 4, 5 and 6. Again you have this, the board, it is symmetrical about 3, from that it is symmetrical about 3. Here we have one again 7 and 8, that is there you have the response for 7 and 8, that is e power j pi by 9 k minus 9. Okay, the number of samples is k minus 9, that is minus 2 and minus 1. For minus 2, that is 7 minus 9 and minus 2, and for minus 1 we have the response, that is for k is equal to 7 and 8. Okay, so we found the response for different samples. Next you have to find the IDFT to get the desired response. That is step 3. Step 3 is you have to find the response or actual response or impulse response. Actual response or impulse response. So you have to take the DFT for the h of k. That is, the relation is h of n is equal to, for IDFT, that is 1 by n. So this is a very important. And then h of 0 plus 2 into real part, that is a symmetrical about 0, it is 2 into real part of summation summation k is equal to 1 to n minus 1 by 2 into h of k e power j into 2 pi by n. What is the n value? N value is equal to 9 k into n. So this is the relation to find the IDFT for the given input sequence. Again 1 by n is 1 by 9 h of 0, so that is the e power 0 is equal to 1 plus 2 into real part. So you have the response for k is equal to 0, that is the 0, and 1 and 2, that is 2 into real part. K is equal to 1 to n minus 1 by 2, that is 9 minus 1, 8 by 2 is equal to 4. H of k is equal to e power minus j 8 pi by 9 into k into e power j into 2 pi by 9 into kn. Okay, next let's solve this. By solving this, I am just taking this is equal to 1 by 9 1 plus 2 into a real part. I'm expanding this, or I'm just taking out summation k is equal to 1 to 4. I'm taking e power minus j 2 pi by 9 common outside, e power minus j 2 pi 9 k, which is equal to n minus, I'm taking e power minus j 2 pi n 2 pi 9 into k. It is k common outside, that is 8 means 4, and then minus minus plus 4 minus n. Okay, that is equal to 1 by 9 1 plus 2 into a real part, that is e power minus I cos theta minus I sin theta, 2 into real part value, that is a cos, 2 into cos, for k value is equal to 1, cos 2 pi by 9 4 minus n, plus for k value is equal to 2 into cos, that is 2 into 2 4 pi by 9 into 4 minus n. Okay, so this is the impulse response or the actual response of the filter. Next, n value is equal to, you know that n is equal to 0 to n minus 1 by 2, that is symmetrical about 0. Here it is symmetrical about 4, so n is equal to 0 to 4, that is n is equal to 0 1 2 3 and 4. So h of 0, for n, put n is equal to 0, 1 plus 2 into cos 2 pi n into 4 minus 0, that is 4 pi, as 8 pi plus 2 into cos 4 into 4 16 pi. So that h of 0 value is equal to 0.073, and h of 1 is equal to minus 0.11, h of 2 is equal to minus 0.059, h of 3 is equal to 0.32, h of 4 is equal to 0.555. Next, here it is symmetrical, it is symmetrical, so it obeys the condition. The condition is h of n minus 1 minus n is equal to h of n. So for other filter coefficient, that is h of 5 is equal to h of 3, that is 9 minus 1 8, 8 minus 5 3, and then h of 6 is equal to h of 2, h of 7 is equal to h of 1, h of 8 is equal to h of 0. So the total filter coefficients are 9 filter coefficients. So h of 5 takes the value of h of 3, and h of 6 takes the value of h of 2, and h of 7 takes the value of h of 1, and h of 8 takes the value of h of 0. Next thing is, I have to find the transfer function, that is the step 4. The transfer function, the formula to find the transfer function, that is h of z is equal to summation n is equal to 0 to n minus 1. Summation n is equal to 0 to n minus 1, h of n into z power minus n. So from this, so for different h values, h of 0 into z power 0 plus h of 1 z power minus 1, h of 2 z power minus 2 plus h of 3 z power minus 3 plus h of 4 z power minus 4 plus h of 5 z power minus 5 plus h of 6 z power minus 6 plus h of 7 z power minus 7 plus h of 8 into z power minus 8. And my filter transfer function is h of 0, it is 0.073 into z power 0 plus h of 1 is minus 0.11 z power minus 1 minus 0.059 into z power minus 2 plus 0.32 into z power minus 3 plus 0.555 into z power minus 4 plus 0.32 into z power minus 5 minus 0.059 into z power minus 6 minus 0.11 into z power minus 7 plus 0.073 into z power minus 8. You just rearrange this equation, rearrange this so that h of z is equal to, you just rearrange 0.073 z power 0 plus z power minus 8 and then minus 0.111 z power minus 1 plus z power minus 7 and then minus 0.059 z power minus 2 plus z power minus 6 and then plus 0.32 is z power minus 3 plus z power minus 5 and then plus 0.555 into z power minus 4. So this is about the transfer function of the filter. Next, we are going to find the frequency response. That is the step 5. For step 5, you have to find the frequency response. So you know the formula to find the frequency response. H of e power j omega is equal to a of 0 plus summation n is equal to 1 to n minus 1 by 2 into a of n cos omega n. A of 0 is equal to h of n minus 1 by 2. A of n is equal to 2 into h of n minus 1 by 2 minus n. So that a of 0 is equal to h of 4. A of 1 is equal to 2 into, that is 4 minus 1, h of 3, and a of 2 is equal to 2 into h of 2. A of 3 is equal to 2 into h of 1. A of 4 is equal to 2 into h of 0. You just multiply this a of 0 and h of 4. A of 0 and h of 4 is 0.555. Same thing. And then a of 1 is equal to into h of 3, 2 into 0.32, which is equal to 0.64. 2 into minus 0.059, which is equal to minus 0.118. 2 into h of 1, that is minus 0.111, and it is equal to minus 0.222. And h of 0, 0.073 is equal to 0.146. And then the equation, the frequency response be a of 0, 0.555 plus 0.64 into cos omega minus 0.118 into cos 2 omega minus 0.222 into cos 3 omega plus 0.146 into cos 4 omega. So this is about the design of the FIR filter using frequency sampling method. Very simple to follow the steps. Based on the given problem, first find the h of k value. That is from that problem, e power minus j n minus 1 by 2, that is 4 omega. Omega, you are sample the k values for different k values, 2 pi by n into k. So that h of k is equal to, we just multiply it, e power minus j 8 pi by 9 into k. Next, we're going to find the response of the filter for different k values. For what all the samples, for what all the different k values, I am going to find the response. So that I am drawing a unit circle. I am bisecting the circle into n minus 1 equal parts. That is the 360 by 9, 40 degree. So that my k value is from 0 to 8. So I am bisecting it 0, 1, 2, 3, 4, 5, 6, 7 and 8. So in that my frequency, my filter response is for 0 to pi by 2. So I am shared it. So where it covers the samples for k is equal to 0, 1 and 2, and it is symmetrical, so that at 7 and 8. So I am rewriting my response as e power minus j 8 by k for k is equal to 0, 1 and 2. For 0 it is 3, 4, 5 and 6. Again it is e power minus j for minus 1 and for minus 2 for value 7 and 8. To find the actual response or the impulse response of that filter, 1 by n into h of 0 plus 2 into real part of summation k is equal to 1 to n minus 1, h of k into e power minus j 2 pi n into kn. I am just taking common outside. Then after finding this values 1 by n, and then I am taking that is 1 by n of this value, 2 into cos 2 pi by 9 4 minus n plus 2 into cos 4 by n by 9 into 4 by 4 minus n. For n value is equal to 0 to n minus 1 by 2, 9 minus 1, 8 by 2 is equal to 4, 0.073. Don't forget to divide the answer by 9. And then by symmetrical property, h of n minus 1 minus n is equal to h of n, and then the transfer function h of n into z power minus n, and then frequency response a of 0 is equal to h of n minus 1 by 2. So after this, the frequency response is 0.55 plus 0.64 into cos omega minus 0.118 into cos 2 omega minus 0.222 into cos 3 omega plus 0.146 into cos 4 omega. Take out the workout problem as an assignment. That is, the response of the filter is h of e power j omega is equal to e power minus j 3 omega, 0 less than or equal to omega less than or equal to pi by 2, 0, pi by 2 less than or equal to omega less than or equal to pi. Determine the filter coefficients. That is h of n for n is equal to 7 using frequency sampling method. Okay, so, try this problem. Post the answer in the comment section. For more problems, subscribe our channel. Okay, thanks for listening. Thank you so much.